Hello friends, good morning and good evening everyone. Your ALP here. So today I am here with one more guest, Mr. Avisek with us. So he is working with Google and he has a wonderful experience in this machine learning, computer vision and multimedia and other areas. We discussed a lot about his experience with mainly the face related talk, how to produce different lip movements by using machine learning technology and all. So these things are mainly useful. For example, say one lecturer is there, he is delivering speech in maybe in English. So how we can convert it into the other language, like say for example Indian languages or any other foreign language. There are translators, but what about the lip movements and all? It's like a dubbing, right? Dubbed movie. So we here by using these machine learning concepts and all, so he is working on a project where his team is working to create all the lip movements also to restructure the lip movements also. So this is one of the sample example, guys. So we discussed a lot about machine learning and computer vision, so how it is important and what are the different things comes under this, and the synthesis of the talking. So talking synthesis with respect to the real time examples, like for example Amazon, how Amazon is working by considering these things. So like that we discuss it, guys. I hope the discussion is useful to you. Keep watch this video till the end, you will get better understanding. If you have any questions or comments or anything, then do comment in the comment section. We are ready to help you. And if you are watching this video for the first time, then do subscribe to this channel so that whenever I am uploading videos, you will get notifications. You can simply click and watch it. So good evening, warm welcome to you for our channel ALP Talks. Nice to meet you.
Yeah, good evening, Ambati. Yeah, really looking forward to this
so
talk. Yeah.
first time I'm watching you directly. It's very nice. Yeah. Okay. Yeah. So just to say a few things, to share the knowledge, I started this channel, and it's almost 1 year old, and it's going well, and almost 90 plus professionals I interviewed till now. Yeah, it's
Great.
somehow it's benefiting the student community and the professionals who are 1 or 2 years experience, so they can get better understanding about it. It's about myself, I can say. So it's your turn here. So just speak few things about yourself, who you are, your educational and some professional background, and then we will discuss a lot of today's topic. Yeah, please proceed here.
Okay.
Thanks for accepting the invitation and being here.
Yeah, thanks, Ambati, for inviting me firstly here. So, hi everyone, this is Avisek. So currently, I'm a research software engineer at Google Research for their Mountain View office. So prior to this, I completed my PhD and master's from IIT Kharagpur. Mainly during, I have worked mainly on machine learning and computer vision stuffs. So my master's was mainly on statistical machine learning, while my PhD was mainly on computer vision, GANs, generative models. And yeah, in the course of that, I did some internships, which made me more passionate about AI and vision. And so yeah, I ended up in the same team where I interned at Google for 2 or 3 summers.
Okay.
So, and right now at Google, we are working on this technology of creating talking humans from just audio. So the idea is you can just provide an audio signal and maybe one static image of a person, and then it will reconstruct very good 3D head movements, photorealistic renderings. So yeah, it's like a digital humans. That's what we are working on.
Okay.
Yes.
Okay. Yeah. So is it like robotics? Robotics, we can say mostly, or how?
It's not robotics as of sense. So we are currently, there are two aspects that we are looking at. One is the photorealistic stuff. So for example, if you look at our last year's CVPR paper where we show that you can take, let's say, an English lecture of a renowned professor, but there are some parts of the world where English might not be known, right? So you can make the same video, translate it to other languages, right? So, but you can do an offline dubbing that looks a little bit unrealistic because you can, let's say, translate it to Spanish or Chinese. Mandarin, but the lip movements will not be coherent with what the
Yeah.
background speaker says, right? So here
Yeah.
our idea was we use a lot of voice cloning technology to convert the same, to maintain the same frequency signature of the original
Mm-hmm.
lecturer. And
Mm-hmm.
at the same time, based on the translated speech, you reconstruct the lip movements photorealistically so that at a first glance, you don't get the feeling, oh, it is a dubbed video. Right. So that's one aspect. Then there are some other demos which we showed mainly in gaming avatars where right now, if you know, like there are the social engaging games where you talk with each other, right? You put on a
Yeah.
headphone and then you talk with your peers. So usually that requires you to enable your webcam, right? So that kind of a
Yeah.
breach of privacy. So this technology is kind of enables like you can shut down your camera. Still with just the audio, you can reconstruct your face or you can create cartoons of yourself so that cartoon will be really photorealistic. So there's a lot of applications enabled from this, and yeah, a very excited field to work
Okay.
on.
Okay. Okay. Yeah. Is this
Yeah.
only for software platforms, like, for example, like using for apps and some in different apps, for example, Zoom or Meet or some other platforms, or it's like a hardware, like a person or physically set up, we can plan it. How the research is going on?
Yeah, so currently it's still software based, right? Like, you don't need any specialized dedicated hardware for doing this.
Mm,
Obviously, you would need GPUs to run it real time.
mm.
But it's, I think, mainly software services that will be benefited from
Okay.
this. So it's still in a research phase. That's why,
Mm,
like, we just came out with the paper last year. We're writing another
mm,
one. So, but there are a lot of possibilities which we show in the paper, which we hope comes out as products,
yeah.
because things need to be really good before it comes out. It's one thing to write a paper, and it's another thing to make it a product.
Yeah.
So, but there are a lot of software services which will be enabled mainly like we are now talking about metaverse,
Yeah.
extended reality. So there you need digital humans, artificial humans, and you need them to make speak, right?
Mm,
So this is a very good effort towards that front.
okay.
Yeah. So currently, the way it's set up, the previous works really needed very dedicated hardwares, like you would need array of RGB cameras to capture the face models and learn 3D models.
Yeah.
But we don't need all this. We do 3D point estimation just from video streams. So it's cheaper in that way, both from cost and execution point of view.
Mm-hmm.
So there's a lot of promise then because as soon as you don't need so much hardware, it
Okay.
reaches to more common people. So yeah.
Yeah. One question I have, for example, you told like us the lecturer or whoever may be delivering. So lip movements and all is different when you are translating for other language. So
Mhm.
how you are able to meet that? We can't change the lip movement, right? Because for example, existing one lecturer, one hour video may be there. So how you can
Mhm.
interpret that? So how it is different from the existing language translators, this technology?
Yeah. So here's the thing. So our model mm, knows, like if you give it an audio spectrogram, it knows how to take a reference image and then modulate the lip region to match what the spectrogram is for, right?
Mm-hmm.
So that's not a challenge because if you give it as an input some audio signal, it will predict the correct lip movements, right? So in case of dubbing scenarios, you just pass it, as we see in the paper, you just pass it some reference face, and it
Okay.
predicts a delta based on that reference. Like, oh, okay, if this is a reference, what should be my change in the lip structure given this is the audio? The bigger thing running behind is the voice cloning stuffs that we use because, for example, you would want, let's say, the voice of Shah Rukh Khan or Amitabh to stay the same, right, irrespective of whatever language you translate. That makes it more realistic.
Yeah.
So that voice cloning technology is there, and then it boils down to, let's say, you need language translation, right, from English
Mm.
you need some way to convert it to text and then from text to another language text and from that language text we convert it to voice
Okay.
maintaining the frequency characteristics. So there are some two or three chains in this. So that is more challenging part because the training, um, a model to predict lip movements from a reference face given an audio. That's solved. It's now how do you synchronize, because that's a tough part, right? Let's say you say I want to go there in English. The Hindi is mujhe udhar jana hai, but the total time duration of these two sentences might not match, right? So there you would need some tricks to
Yeah.
fasten the video or reduce the frame rate a bit.
Yes.
So those are very nitty-gritty details, but the main
Yes.
thing is this voice technology, voice cloning, lip movement prediction, and this automatic speech conversion to
Okay.
text. Yeah.
Yeah.
So all these
So
things working together, we're still working. It's still not that good.
okay.
It's
Okay.
working, but we are still improving. So yes, a lot of things will be enabled once this kind of things get more realistic, photorealistic. Yeah.
Yeah. So if this is the
I think
case,
you might have
then
seen yeah, sorry, I was just saying you might have seen the recent Cadbury ad, right, where Shah Rukh Khan
yeah.
says infinite possibilities of stored names, right? So that's like a technology you just feed in one word, and from that word it creates the lip movements. Yes, every word can be broken down into syllables. So once you know the syllables, you know how the lip movement should be. So yeah, so that's like a very good example of how this artificial humans will come into picture of scaling up a lot of things.
Okay. Yeah. So you are going to reconstruct the entire video also, right? By
Mainly, we are the face region because
mm,
that's what we are looking at, right?
okay.
Mainly
Okay.
dubbing scenario. That's what matters. Yeah.
Okay. So is it like only one person should be there in the background, or it's like entire movie? This can entire there can be multiple people, multiple faces in the background. So how the
Yeah. So
situation is
currently,
there?
we started off with a single person. You start easy, start small. That's
Mm,
what we showed in the paper also.
mm-hmm.
Uh, so there are some works also going on where you can do for a number of subjects.
Yeah.
For our group, we were doing personalized models. So we were training model for each subject because we feel like every subject has their own way of speaking. So you want to
Mm,
capture that. So that's a benefit of having
yeah.
person-specific model. But there's a downside that, as you were saying, let's say in movie there are 100 characters, so you need 100 different models.
Mm,
So there are some plans we are looking at
okay.
how to scale up to infinite number of people. In fact, we have to do going forward, but right now we were more focused on person specific deployment. There are a lot of kind of scenarios like the
Mm-hmm.
online tutorials are a great
Mm-hmm.
example,
Yeah.
like medical bulletins, announcements, educational videos. All of those mainly have one or two narrators.
Mm.
Let's say the BBC documentaries, all of them like
Yes.
so
Yes.
that there are also use cases for personalized
Yeah. Yes.
models where
Yes.
you have at max one or two person in the screen. Yeah.
Yeah. The applications are like yes. Yes. One or two most applications are there. Okay.
Yeah,
Okay.
there are numerous. Yeah.
So, what's in your mind? You are going to construct only the the surrounding region with a new fixers like that, or how?
Currently, we do that. Like we just predict the lower mouth region
Mm.
because the upper mouth region is kind of, you can say, you can copy from a reference frame. Well, obviously, we do some 3D warping and all this because based on how your lower lip is, it can dictate to some extent how your upper portion of the face has moved.
Okay.
Well, currently in the paper which we had, we don't predict the upper part. We kind of have a reference frame. We estimate what is the estimated movement and just copy. We do 3D warping. But the lower part of the face is completely predicted.
Mm.
So,
Okay.
well, we were also looking at stuffs like predicting the entire face. Why not? GANs are there. You can do a lot of photorealistic renderings. So there are some teams collaborating with us who is also looking at full face reconstruction.
Mm.
I mean, for some cases, like where you have a lot of emotions and all, it might be meaningful to create the big eyes or small eyes based on speech. So there are some works going on along those lines. Yeah.
Okay. Is there any working models already somewhere in the world, or it's the first of kind? The team is started. Your team is started. Or what's
Oh, you
the?
mean as a
Mm.
You
This,
mean as a product from
yeah,
Google? I don't think so.
okay,
It's because we didn't launch it.
okay,
Because we still feel a lot of work needs to be done.
okay.
Uh, yeah, but we are hopeful. I was working on it for the last 1.5, 2 years.
Hmm.
So it's still in a pretty good shape, but need to make it better. There are some demos coming from other companies like NVIDIA also showcase their digital avatars in Zoom meetings.
Hmm.
You might have seen Microsoft Mesh Teams showing their 3D presence. So yeah, related works. A lot of companies, everyone coming having the same goal of having digital humans. I think the pandemic and the new kind of meeting scenario also is accelerating the research in this space. Yeah.
That's true. This pandemic, mostly the digital things are getting more important.
Yeah.
Yeah, yeah,
Right, right. Only the Cadbury ad I saw, I felt like it really went into deployment where they used. I think that was one of the Indian startups also,
okay,
if I'm not wrong. Yeah.
yeah, yeah, okay. So I see another three different areas from your profile, mainly the machine learning area related and the computer vision related, and other one the multimedia related. So we will speak a
Mm,
few things. I mean, we will spend some time on each topic. So let's talk about the machine learning related. So why you think this is important,
okay.
and where this the machine learning plays a major role in which area or which product. So let's can you give
Hmm.
some brief idea on it? Yeah.
Yeah, yeah, sure. So, yeah, I think the time I started machine learning, 2015, maybe. Yeah. So I think those were the times when, as soon as you say machine learning, people used to think computer vision or NLP, right? Like
Mm,
the concepts used to be there, but somehow these two domains got a lot of limelight, a lot of press coverages.
mm,
So anyway, you just thought, okay, let's apply to image processing, computer vision, or NLP stuffs. But now people are understanding that you need predictive models, right?
okay.
So it would be harsh to say that things were not there before. Obviously, all the statistical models, everything was still there. People were using it. It's just that I think people have now felt the need to use it much more instead of relying on close bounded analytical solutions. So where do you need machine learning? So machine learning would be needed in cases where you want to optimize something, right? And you don't have, let's say, a close bounded solution. So if you have any objective function, right, and you know how to solve it by hand, right, you don't need any iterative processes, right? Some
Yeah.
estimation processes, right? You would get the answer directly. So, but you have now so many n different variables coming into the picture. You have non-convex surfaces of the losses, whatever domain you're
Mm,
talking about. So
mm,
people are thinking of, let's say, let's optimize this in an iterative way.
mm,
And there used to be a lot of methods, right? It's just because now you have the GPUs, then this the de facto choice of gradient descent based optimization started becoming very common. And then you came the deep learning era, right? So it was very straightforward to use for your images and videos, like the matrix dimension.
yeah.
But then also so again, LSTMs, RNN, they're a very old concept.
Mm,
But somehow people didn't appreciate, maybe lack of GPUs again. Those kind of models began to take in unstructured, data which are in time series, right?
mm,
Not in just in simple matrix format. So both of these things like really pushed open. I mean, the three things like you have the CNNs to process
mm,
metrics form data, you have this RNNs to process time series data, and mostly then you have the GPUs which can make it realistic to train. Like so, then every domain of a company started realizing, oh, well, let's not waste time on doing what we used to do is just plug in a
mm,
deep learning model and just get some results out of that. That
mm,
works well to majority extent. And I think people got useful representations across all fields. Like now you'd find machine learning being used where not, from drug discovery, like
Mm.
just now, like some months before,
Yeah.
DeepMind came with the default uh, uh, formulation, and also reinforcement learning gained popularity again. It's a very age-old topic, like controls and reinforcement learning, where somehow it was not the deep reinforcement learning, which
Mm.
enables your RL into TL framework. But once it got started, now a lot of things are getting enabled. So, for example, I was talking of this default paper from
Mhm.
DeepMind, right? And then the DeepMind guys are using that same concept to do drug discovery. So it's being used in drug discovery, it's being used in cryptography, it's being used in, let's say, agricultural, it's
Mhm.
used in finance prediction. So why not? So ML is everywhere. It's just because I think people now have a very, it has now become kind of a service, right? So it's no longer you sit down with a pen and paper, you're solving maths, you're bringing out equation. It's like, uh, okay, you have a black box, you give it something, and majority of the time it throws you decent results. So we need to
Okay.
be sure majority of the times, because you need expert people to interpret what's coming out.
Yeah. Yeah.
But it works out of the box majority of the time, and it learns pretty good representations, right? So that's why I think most of the companies will eventually start. And now we have so much data, like data collection has also become a priority for a lot of companies, right?
Yeah.
So you have data, you have resources, GPUs, you have the basics of deep learning, neural nets, gradient descent. So everything is perfectly fit to use ML. So I see like most of the companies using that, and I can think of any field where it's not being used. Even the physics people, right? Like there are some problems which doesn't have close bounded solution. You would need a lot of computer simulations to come up with a solution.
Yeah.
If you follow Jan LeCun's post, he shares this kind of updates, and then you can use deep learning to predict like the outcome of three system, two system model.
Yeah.
So here's the baseline. Anywhere you come up with an objective function which you need to minimize or maximize, you have the resources to do compute. People are using these days, and yeah, you need to be sure what you're doing. Right now, what we saw the example of Zillow's use case.
Mm.
It's unfortunate, but that's the kind of thing we should be also aware of. That whatever comes out of your machine learning models, you still need good maths and statistics people from traditional background to make sure that the predictions are coming out right and it makes sense.
Mm.
Yeah.
Yeah. Yeah. Okay. So generally, is these are all like a programming only, right? So, for example, whatever there should be one objective function for doing number of iterations and for finding or coming to the convergence per particular towards an optimum cost or optimum volume or it can be like optimum area. So whatever it may be. So
Hmm.
the naming like machine learning, so is it like maybe it is in programming in different languages only, right? Like maybe in MATLAB, it may be Python, it may be in other
Hmm.
language coding
Right.
only, right? The objective function and all. So then,
Yeah.
yeah, why it is elaborated like machine learning and making it a different subject like that? So is it a completely different way or in
Uh,
layman terms or how it is?
uh, so different compared to what? Like, do you have anything other reference in mind? Like different from what?
Different from the existing, for example, programming, whatever the people are writing the coding and all. So
Hmm.
there is
Hmm.
also some objective will be there, objective function will be there. They
Hmm.
may aim maybe to reduce the cost, or like you told.
Yeah.
There are also normal things are happening. So how the
Hmm.
machine learning is those concepts are different from the existing reality or people whatever the iterative programs whatever people are using. So
Right. Right. I think that the term learning was proposed, like if you go by textbook definition,
mm,
as Tom Mitchell says, it's like making a system learn from experiences, right? So you're making a system learn and from experiences. So that's the machine component because you're making a machine learn. And why is it
okay.
learning? Because it is facing some experiences. It is either getting penalized or it is getting rewarded. So, and in the process, it learns what it needs to do good to reach its optimum state, right? So when it started as a supervised learning, right? Majority of the time. So there you would feed the system, okay, this is a positive example, this is a negative example. Okay, this is a positive example, this is a negative example. Right. And then you would, as because you have given the labels, and then you ask the machine to predict, right? Okay, if this is an input, what do you think the output is? This is positive or negative? A very simple words, right? So if it says
Okay.
positive, okay, you get, oh, great work done. So you get a positive reward, right? And somehow, if it says negative, then you
Yeah.
penalize it, right? In case you increase the cost function.
Mm.
And that increase of cost function internally changes the state of the machine. So the machine means the parameters, whatever is your parameter of your network. Can
Mm-hmm.
be it can be neural nets, it can be SVMs, logistic regression, anything which can be tuned, right? So it's
Yeah.
something, it's like it has a brain inside, and then with the signals, you are training it to predict correctly, right? So it's learning
Yeah.
how it should change its internal brain to predict correctly when faced with an external input, right? So
Yeah.
I think that would be a simple way of saying why the two terms machine and learning coming into
Mm.
picture.
Yeah.
After that, there are a lot of things came like unsupervised, self-supervised learning. But to begin with, the machine learning era, like it's easy to understand supervised learning, and then getting rewarded or penalized comes from that. So you can
Mm-hmm.
learn, right? Yeah.
Yeah, clear cut explanation. Yeah. So I have one more doubt coming in the mind. So how there should be more data, right? First of all, for these machine learning concepts and all. So like you told, learn by experience. So how it can experience those things. So if, how much time it will need. For example, for getting real time experiences, it needs like real time again, so it should
Mm,
be like again virtual experience. So how we can
mm.
make it experience those different situations in a small short span, and it can learn easily. So how we can comment on that?
Yeah, yeah, that's a very, very wide area of work going
Mm,
on. So
mm,
traditionally, what we people used to do, you offline collect a lot of data, right? And
mm.
you train your models
Okay.
or optimize your models, right?
Mm,
And then you deploy it to the real world, and you expect that data which you used during offline training is a good representation of what it will face in real life, right?
mm,
So
mm.
there is no distribution shift from which you sampled your training data and from where you're sampling your production data. So that really depends on the expertise of the data collectors, right? So
Mm, mm,
that's a very bottleneck, right? Like nowadays, you need thousands and millions of data points to train these deep nets, right? Uh, so here's the thing: either you spend thousands of dollars, collect data sets like ImageNet, MS Coco, Pascal, YouTube videos,
mm,
and since because you spend millions of hours, so all these data sets of videos, like they have million hours watch time, right? So
mm.
it basically is there's no guarantee that it covers the entire world around us, but you can expect, okay, it's doing decent work. So there cannot be anything else which YouTube dataset doesn't have. But it's not always possible, right?
Yeah.
So there is this also concepts of online learning.
Mm,
So you collect data to some extent, right? And you train a model, you expect it to perform decently, right? But then another customer data comes with a label. Let's say someone clicks something in Amazon after
mm,
looking at images.
mm.
Maybe your model says, okay, this customer will not buy, but somehow the customer buys, right? So that goes as an additional in the production signal, right? So then you have a lot of online learning algorithms which iteratively changes the state of your uh, ML models for per sample basis, or maybe at the end of the day you collect 100 such online real-time samples and you didn't refresh your model overnight. So that's also one way of training your model, and that's also quite commonly used in a lot of real-time ML models because getting customer data, millions of customer data always is not possible. So you collect a bit of data, rely on it to give decent performance, but you keep on learning. So there's this concept of lifelong learning, which is very popular because you need to keep on learning forever because the dynamics of the data changes. I mean, there's also this thing like 2 years ago, how people used to shop on Amazon. The overall mentality and psychology of the customer has changed, right? Like we, as a younger generation, we nowadays might be more tend to buy e-gadgets than maybe
That's
when we were
true.
students, right? When
Yeah.
Amazon first came into India, when we were students, 2012 or 13, we would be skeptic to buy. Oh, we should buy. Oh, let's go to a local shop and buy. But maybe now, oh, this is there. Just click it, buy it. So overall psychology has changed, but that doesn't. But so you have to keep on updating your model, right? So online learning is very very important, and it's very commonly used by a lot of tech giants. And
Yeah.
then there's this other way of collecting data, not collecting data, but synthesizing data, where like I've got some works on that. So you try to generate data, fake data, like let's say you want to predict, you want to train your, let's say, some Amazon image classifier to predict, okay, this is a school bag, this is a bicycle. And you don't go on collecting so many school bags and bicycle. You just collect some few thousand examples and then rely on state-of-the-art generative models now, GANs, VAs, VQVAs, to synthesize such fake data, millions of fake data. So, and then you train your models because there's no one is stopping you to generate millions of data now. So there's this challenge, like how realistic you can generate. So that's another area of research which is
Yeah.
now
Yeah.
gaining a lot of popularity. Because if you synthesize data, you save your money for company. You don't need annotators. You save your man hours. And yeah, there are wonderful things you can do with generative models.
Yeah.
Yeah,
Yeah.
I think that answers some of the aspects of data for modern
Yes.
ML
Yes. Yes.
frameworks.
Yeah.
Yeah.
It's a clear Abhishek. So like machine learning general discussion, it's a very nice. Yeah, there are other term. We will move to the other term that is like a computer vision. So
Hmm.
how it is different from the again same machine learning? How this the term and other applications are generally performs in the real time world. So let's
Mhm.
discuss on this topic. Yeah, computer vision.
Yeah, so computer vision doesn't really have to depend on machine learning. I mean,
Mm-hmm.
after you go to an advanced stage, then only both of them start mingling with each other.
Mm-hmm.
Computer vision has its roots in image processing, right? So you
Okay.
have your sensors, cameras, it captures your 3D world as a
Mm.
2D matrix, right, in your sensors, right?
Mm.
So as soon as it captures it as a matrix, you start doing your linear algebra steps, right? So and you start doing your maths as soon as you get your matrix. So that's how image processing started, right? So for example, like just for anyone beginners, you capture an image is a matrix, and you then say, okay, I want to find the vertical edges. So what do you do for getting vertical edges? You just take gradient along the horizontal directions, right? So you get the variations along the perpendicular direction. So you get a vertical image, enhanced image, right?
Mm.
So all these small concepts were the basic blocks of image processing, and and then computer vision is like a super layer name given to that. It's just, I would say, everything is image or video processing, right? It's
Yeah.
just because computer is doing that and it's providing a vision, then you say, oh, it's a computer vision, right? So and then, yeah, there are more sophisticated stuff like now people do 3D depth analysis,
Mm.
segmentation, right? Object detection, recognition.
Mm.
So all of those really does image processing, right? But
That's it.
majorly you will now hear saying, "Oh, I work on computer vision," uh, but it's just because I think it goes down history where the famous people like Elliot Sisserman's book or Forson's book, where they said, "Okay, fundamentals of computer vision." They do fundamentals of image processing, but they coined the term and it has gone down the history as computer vision. So as you
Yeah.
can see, there's no direct relation, integrate relation for machine learning to come. Why do you need
Mm.
that? Because again, let's say people used to do depth prediction, right? You get multiple views You get multiple cameras, you have close bounded, very good solutions to find out depth. But what if now you want to predict it from a single camera? Then you just take millions of examples, like, okay, this is my scene. I know this is my ground truth depth. Okay, let me train a machine learning model to do that. So that's why ML comes in where you don't have feasibility of doing close bounded vision solutions. And then nowadays people are doing crazy stuff with vision, right? They're predicting human movements, trajectory analysis, segmentation. This cannot be done with just analytical pen and
Yeah.
paper solution. I mean, it's too complex for any
Yeah.
human being to come up with exact logics per pixel level. So you just give the machine enough examples, follow it up with some principles, because I always stress on that deep learning is not a black box. You do deep learning, but you also augment it with some domain knowledge, and both of this combining together works really nice. So now that's why computer vision and machine learning has gone hand to hand, because of the nature of the tough problems we are solving. If you look at the very best papers of the early 90s, late 90s or early 2000s, they were mathematically rigorous papers where you wouldn't need
Yeah.
much of machine learning. Only linear algebra optimization, convex, non-convex optimization. So there you wouldn't see much of the fancy terms coming into picture, but it's becoming hard now because the crazy problems that we are solving. You need abstract learning, representation learning, which is enabled by deep learning.
Yeah.
So that's why now you see both the terms coined together at the same time.
Yeah. 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 Okay. Okay.
Yeah, yeah. So if
Nice.
you take any beginner's course in computer vision, none of them will encourage you to use machine learning. In fact, majority of the professors tell you to code it from scratch using C++ or Python.
Okay.
Yeah.
Okay. Okay. Yeah. And I think we discussed about the talking synthesis, right? 3D talking
Mhm.
synthesis, face synthesis, like a lip movement and all. Initially,
Yes,
but
yes,
that's what your project, right?
yes,
Yeah.
yes. I'm currently working in the same team and the same project. Yeah.
Yeah. Yeah. Yeah. Okay. Okay.
I mean, yeah, that was also my internship projects.
Mm.
So I'm just continuing that as full time now. Yeah.
Okay, okay, yeah. And
Yeah.
I'm coming to the your research interest areas. I think you did some researches on Google, Facebook, Twitter, and all. So can you comment
Hmm.
how what's your final understanding with the different platforms and all? I think you spent some time right on those areas.
Uh, can you elaborate what you mean by understanding of platforms?
Yeah, for example, I think you have you did some research on these the Google, Facebook, and these areas,
Mhm.
right?
Yeah, yeah, yeah.
Yeah, yeah. So did you get it research internship? That is the internship, I think.
Yes.
Yeah,
Yeah, yeah, all of them were research internships. Yes,
yeah.
correct.
So yeah, yeah. Can you speak about those things generally so that it can give some better understanding how each platforms are to
Yes.
yeah. So
Mhm.
in terms of not in
So
terms
I,
of usage, but the public common public knows how we are
yeah.
using it, and but in terms of maybe backend or development side or data side.
Mhm.
So can you comment those? Can you differentiate or can you discuss the stuff?
Right, right.
Yeah, yeah,
Yeah. I think my Twitter's internship was my first time, like in a tech company abroad. But
yeah.
I was also not sure that Twitter does computer vision stuff. I was also a
Mhm.
new beginner at that time. But
Okay.
I was surprised to see one of their very famous papers on super resolution. So that caught my eyes. And then when I interned with them, I saw how it is useful, because nowadays platforms like Twitter and Facebook, we consume a lot of multimedia data, right? It's no
Yeah,
longer about just text. You
yeah,
share your videos, you share your images, you live stream sports. So there it is. Like there is the need for computer vision people to plug in. So
yeah,
there I was working at Twitter on video super resolution, especially if you want to broadcast, they wanted to broadcast NFL videos and stuff like that. So for the end user, you might still be streaming at 240p, but it can do upsampling on your device and artificially make it 720p. So that's good, right? You just save your
mm,
bandwidth, but you still get good clarity of data.
okay,
So Twitter does work on that. There's a good need for computer vision people there.
Mm-hmm.
But I think the team now, that was a very awesome team which I interned at London. It was actually a startup called Magic Pony. Before I
Mm-hmm.
joined, they were acquired by Twitter. So
Okay.
very energetic people they were. I think they have shifted their focus now to recommendation systems because that's also a very interesting research area to work. And of course, on Facebook, we all know like we use a lot of multimedia stuffs, right? So at
Yeah.
Facebook, I was working on, let's say, what was I working on? Yeah, for human pose estimation. So,
Mm.
uh, so, so you do this funny avatars, right, on your
Yeah.
faces and bodies. You get all these effects, but for drawing that correctly, you need to track your body, right, in 3D space very accurately.
Mm-hmm.
But then only you can morph like the cartoon faces and the uh, characters that you synthetically put on. So
Yeah.
they needed a very lightweight solution for doing human pose estimation on
Mm-hmm.
videos. So I
Okay.
was working on that team, and it's public. You can see it's called Mobile RCNN.
Mm-hmm.
Uh, sorry, Mobile Mask RCNN. So it
Okay.
basically does human pose estimation. Yeah, and at Google, I've been majorly working on this project and digital humans. I
Okay.
work on VR space. So yeah, at Google, I interned twice as intern and then 1 year as a remote intern. So it's a lot of effort that put into the first paper coming out. And from an experience point of view, like all these companies are super cool to work with. Like you will feel like you are in a startup with just enormous resources to work with. And yeah, the people there are very open to research. Publishing paper. I usually used to select teams who have inclination to publish papers
Mm.
because that makes it possible to work on more open-ended research problems.
Yeah.
Obviously, there has to be greater number of teams who are more interested in deployment, else who is going to give the revenues. But at
Yeah.
least when you search, you can maybe try to search people who work with papers more. So that
Mhm.
gives you the chance to work with open-ended research.
Yeah.
And yeah, that's what I recently shared over LinkedIn also. Like previously, like we used to think that getting these internships might be tough from India, but I got the feeling that if you do start decently in your PhD, then nowadays the trend is moving everything to remote. Like people are opening up worldwide geographically, so it's much more, I think, even more easier now than it was during my time in 2016, 17, 18.
Yeah.
But yeah, we should be open-minded. If we do good work, then you do get chance to intern at this top research labs. No doubt the competition is very tough there because you have very bright students coming from all over the world, but they do take into consideration that. So it's just a suggestion that to the PhDs who are starting out that do try to apply to these places
Yeah.
because we might sit in our academic labs and good research, but once in a while it's advisable to come out of academics and work in corporate research. Maybe you will like or not like, but it's good to have one more perspective. It's a totally different way of approaching. Firstly, you get like say tens and twenties of GPUs to work with. Who doesn't like that? Then you have this corporate mentality. Okay, we have a research problem, but does it fit to a product that can serve the people? Majority of the research teams work like that. Maybe there are very fundamental teams like in DeepMind or OpenAI who work on abstract AI with a longer term in mind.
Okay. Mm.
That might interest some people also.
Yeah.
But yeah, do reach out to these labs in the hope. Even in India now, these research labs are opening. Google Research is there, Microsoft Research does good job, IBM Research is there. So we should try out to come out of our PhD lab once in a while, spend a summer
Mm.
or two. It also builds up good rapport, right?
Yeah.
Anytime you want to move to industry, it's always good to have something on your CV because then it creates a credibility that, okay, this candidate can perform nice
Mm.
coming to corporate research. You might be pretty good in your lab research, but if you have one or two internships, it gives you that extra edge
Yeah.
that, okay, because you can trust that, okay, the candidate has worked at a decent large scale lab. So it would be easy for him or her to get onboarded quickly into large scale industrial deployment. Yeah.
Yeah, very nice. So a lot of guidance for newcomers and freshers. Yeah.
Yeah. Let's observe. Yeah.
Yeah. Nice, Abhishek, and we should respect our time also. So many things we discussed today about machine learning, computer vision, and other stuff. Very nice. So
Yeah.
the
Yeah, good to talk with you too.
I can't say this is the end today. This is just a start for our combination. We are going to do
Yeah, sure.
sessions also in the future with the small topics. Yeah.
Yeah, sure.
So thank you. Thanks a lot, dear. Thanks for being and sharing your knowledge and all. Thanks a lot. We will meet
Yes,
in
thank
another
you.
video. Bye.
Okay, bye. Have a nice day. Bye
Yeah.
bye.
Thanks for watching. If you have any questions or comments or anything, then do comment in the comment section. And please subscribe to this channel for many more updates. We will meet in another video. Bye.